Hello everyone, I hope you all are doing well. In today's class, I am going to introduce the second unit concepts present in the search engines. The second unit consisting of crawls and feeds. As part of the crawls and the feeds, we are going to learn few of the concepts about what is meant by crawling, what is a crawler, how the crawler is working, and what is a feed, and what are the importance of the feeds. As part of the crawls and the feeds, we are going to learn few of the concepts present in the unit 2 or as follows. The first concept is about the crawls and the feeds. As part of it, we are going to cover few of the concepts like deciding what to search. And the second one is crawling the web. Third one, crawling documents and email. Next one, document feeds. Next concept is the conversion problem. These are all the concepts we are going to cover as part of the crawls and the feeds. Now, we will try to understand one of the question here, deciding what to search. Now, you think of it once. Whenever you are thinking about what to search, I am going to ask a small question. So that one is, what should we search? What should we search? Now everyone please think about it once. Whenever you are before the Google, whenever you want to find any particular information, you want to retrieve, what you can do simply, you just open the Google and try to get the information from the Google. Most probably if you ask any relative question or any reasonable question or a general question, whatever the question you want to ask the Google, it obviously try to answer for your question. So simply I am giving the answer as everything you possibly can. My question is, what should we search? The simple answer is everything you possibly can. Now we'll try to understand that the importance of the technology, as we know that the technology is developing like leaps and the dumps. Now the great technology can make a good search engine even better. Obviously the technology play an important role in the efficiency of the search engine, and if right documents, I'm going to talk about the right documents. If the right documents are not stored in the search engine, for example, if you are searching for any particular information, about that particular information, if the database is not having the relative information or good information about it, then what will be happen? Now you think of it, if the right documents are not stored in the search engine, no such technique will be able to find the relevant information. Obviously you will try to understand that if the right documents are not stored in the search engine, you do not get the relevant information. And next, we will try to understand the importance of adding the documents every day to the search engine. Every time a search engine adds another document, what it is. So if you see in our day-to-day life, the web is increasing like in a huge fashion, and the documents are adding in a more efficient way. So what we can try to understand, as all the people are using the technology in an effective way, all the people are trying to develop the websites and try to maintaining their blogs. Obviously so many new documents are going to add to the web. So the number, whenever the search engine is adding the number of documents, the number of questions it can answer increases. For example, up to now in the World Wide Web there are 100 documents having the information about search engine subject. If I started my own website and I am going to upload the documents about the search engine subject, then 101th document is added and 101th website is added for the web. Whenever a person is trying to get the information about it, then he is able to get the answer in a more efficient way, because the documents are added, then the more information is added to the web. Now here is a one problem. On the other hand, adding many poor quality documents. If we add many poor quality documents, what will be happen? Then obviously it shows the effect on effectiveness and obviously efficiency. As we try to understand, it increases the burden on the ranking process. It increases the burden on the ranking process. If the number of documents are more on the web, then it is a difficult task to process. It is a difficult task to process for the search engine in a efficient way and effective way. So to find only the best documents to show to the user. So what we are trying to understand, in regular days, so many documents are adding to the search engines. If the documents are adding or qualitative, then the search engine is going to give the better results. If the documents are poor, then obviously it shows the effect on effectiveness and efficiency. The next point is going to discuss about documents can become less useful. Documents become less useful over the time for example, if you want to know today's stock market, report, only if you care about what happened yesterday. So up to yesterday, there is analysis about the stock market and a lot of information is available and a lot of documents about the stock market analysis is available. But very few of the people are going to take the support of yesterday's information about this stock market. So obviously what is going to happen, the web is increasing in a manner that shows the effect on effectiveness and efficiency. Next concept is about crawling the web. Crawling, or we can also call it as spidering. We can also call it as the spidering. When you go into the clear details about the crawling the web, so web, it is a collection of huge documents. Let me say that what are the documents? It may consisting of PDF documents, HTML documents, XML documents, and so many documents available on the web. So the web consisting of huge collection of the documents. Whenever the crawler is going to find or scan the web, it is going to identify all the documents. So to build search engine that searches the web pages, you first need copy of pages. You try to understand here in a clear manner. Whenever you want to get any information from the Google, obviously the people behind the Google, they need to maintain a lot of information about what they want to give. For example, you want to know about any particular information about Mahatma Gandhi Garu. Then obviously the people who are maintaining about the Mahatma Gandhi's information in websites or blogs, they need to have the storage. So that's what here is indicating, copy of the pages that you want to search. Then only you are able to retrieve the information. Next, web pages are particularly easy to copy. They are easy to copy since they are meant to be retrieved over the internet by browsers. You're going to retrieve by the browsers. Now you have a question. How to get the data from the place it is stored to the search engine? How to get the data from the place it is stored to the search engine? Now everyone think about this question. So every day we are trying to search the information on the web, or you are trying to get the information on the Google. Have you thought of any time? Now if you think about it, you will come to know a few of the points about what is happening in the background of the crawling. So what is meant by crawling? as part of this one we are going to understand it. Crawling, finding and downloading the web pages automatically is called crawling. Finding and downloading the web pages automatically is called crawling. The program behind the crawling process, we are simply calling it as a web crawler, and a program that downloads pages is called a web crawler. So the process of finding and downloading the web pages, we are calling it as a crawling, and the program that downloads the pages is called web crawler. Simply, if you understand, as I already told you, crawling is also occasionally referred to as spidering. Crawling is occasionally referred to as the spidering, and the crawler sometimes it is referred to as the spider. Next, here are few of the challenges to crawl web pages. While the crawling is going on, here are few challenges. The main two challenges are, the first one is sheer scale of the web. So what is meant by sheer scale of the web? As we are trying to understand, as the web is increasing like huge millions of the documents in our day-to-day lives, trying to identify the particular document for the particular information is a difficult task. So if the collection of the documents are increasing in the web in a day-to-day, then obviously it is a very difficult task to find the particular document. Here, sheer scale of web, there are at least. Now we are going to discuss about challenges to crawling web pages. Sheer scale of the web and not under the control of the people. These two are the challenges we are going to understand about while the crawling is going on the web. What is meant by sheer scale of the web? If you try to understand about the sheer scale of the web, so as we already know that web is already consisting of huge millions of the documents. In regular days, the people are trying to add more number of documents to the web. Obviously, the collection of the documents are increasing day to day. Among all the documents, identifying the particular document for the particular query or the web search query is a very difficult task. That's why the sheer scale of the web is the one of the challenge for the crawling of web pages. And another one, web pages are usually not under the control of the people building the search engine database. All the time the web pages are not under the control of the people who designed the search engine databases. So search engine people will maintain the database. Obviously some of the documents are maintained in other databases also. Sometimes it's a very difficult task to go and maintain the web pages all the time in the search engine database. They are not in the control. That is also one of the problems. These are the two challenges. Sheer scale of the web and web pages are usually not under the control of the people building the search engine database. Next, we are going to understand the concepts present in the crawling the web. So, as we try to understand crawling the web, these are all the concepts we are going to study as part of crawling the web. So, the first one is retrieving web pages, the web crawler, freshness, focused crawling, deep web, sitemaps, and last one is distributed crawling. As part of crawling the web, we are going to cover retrieving. As part of crawling the web, we are going to cover all these concepts. Now we will go one by one in detail. The first one is about retrieving web pages. Try to understand. As part of the retrieving web pages, we are going to hear a few of the words like URL and another word HTTP DNS. These are all the words we are going to understand and we are going to listen as part of retrieving web pages. What is retrieving web pages? We have to understand in a very clear manner. So, as we already know, the web consisting of huge collection of the documents, and whenever it is consisting of the huge collection of the documents, we are trying to retrieve the web pages. How we are going to retrieve the web pages? Here, each web page on the internet has its unique URL. So each web page in the internet having unique URL. That's what we are simply calling it as Uniform Resource Locator. Uniform Resource Locator, simply abbreviated as URL. Simply abbreviated as URL. What is the purpose of URL and what the URL consisting of and what it is responsible for? The URL used to describe web page has three parts. The URL used to describe the web page that has three parts. What are the three parts we are having? The first one is the scheme, second one is the host name, and the third one is the resource name. First one is the scheme, second one is the host name, and the third one is the resource name. Now we will try to understand what is scheme and what is host name and what is resource. Web pages are stored on the web servers. So where the web pages are stored? Generally on the web servers. That is going to use the protocol. What is the protocol it is going to use? It is going to use the HTTP protocol. That's simply the full form of the HTTP is Hypertext Transfer Protocol, or abbreviated it as HTTP. For what? To exchange information with the client software. I hope you are trying to understand that each web page is associated with one unique URL. That's what we are simply calling it as a uniform resource locator, and each and every web page has the three parts that is described by the URL as scheme, host name, and resource name. The web pages are stored on the web servers, which uses the protocol. We are calling it as a Hypertext Transfer Protocol, which is used to exchange the information with the client software. So here the person who is sending the request is the client. The person behind in the background, we are calling it as the server. It is going to process it and it is going to serve for the client. So these are the few points we are trying to understand as part of the retrieving web pages. And if we can go in more detail, we try to elaborate the URL having, or the web page is having the three parts that is described by the URL as follows. Now we try to understand this example. The computer's name. What is the computer's name? Here is www.csumass.edu. So you observe here www.csumass.edu. I am calling this one as the host name. And the scheme is HTTP. And here the scheme we are calling it as HTTP. And the resource name is, this is the resource name, csinfo/people.html. Now I am trying to explain in a more detailed manner that a web page is having three parts that is described by the URL as follows: scheme, host name, and the resource name. If you try to see this URL http://www.csumass.edu, csinformationpeople.html, http is the scheme, and this is the host name, and this is the resource name present in the computer. Now you try to understand, the computer's name is this one. This is the name of the computer. And which is the computer in the University of Massachusetts, which is the computer present in the University of the Massachusetts. That is the name of the computer, and which is present in the CSE department. This URL refers to the page on the computer. On that computer, that's we are calling it as csinformationpeople.html. So the URL having the three parts like this, and simply you are calling it as a scheme, and this is the computer name present in the Massachusetts Institute of Technology in the department of CSE, and that particular computer consisting of the resource as like this. So this is the resource name. So this is about scheme, host name and the resource name. Next, the next concept prior to that we'll be having one more elaborated point about the clients. What are the clients here? So you try to understand. Here I am using two words. One is web browsers and web crawlers. Web browsers and web crawlers are two different kinds of web clients. These are two different kinds of the web clients, but both fetch the pages in the same way. I hope you are trying to understanding my points. Web browser and web crawler, both are the clients. So for what purpose we are using them? They are using for the purpose of fetching the pages. So that's about the web browser and the web crawler. Now, how these two clients are interacting with the servers? We are trying to understand the process behind how the client is going to interact with the server. Here is first, the client program connects. The client, what is the client here? Either web browser or the web crawler. They are the clients. So the client program connects to the domain name system. So domain name system, that is simply abbreviated as DNS server. The first program connects to the domain name system. What the DNS do? The DNS server will translate the host name into the IP address. The DNS server is going to translate the host name into the IP address. So here the host name into the internet protocol address or IP address, we are simply calling it as. So this IP address may be of typically 32 bits long. On the different networks it may be the 182-bit IP address. Here what it is going to do is, the client is going to connect with the DNS server, and the DNS server is going to translate the host name into the internet protocol address. This IP address may be the 32-bit or the 128-bit. What the client do in the next? The program that attempts to connect to the server. The program that attempts to connect the server computer with that IP address. So that program is going to connect with the server with what? The particular IP address. So whatever the host name is converted into the IP address, that is going to be connected. Once the connection is established, the client program sends the HTTP request. The client program sends the HTTP request to build web server to request a page. The most common HTTP request type is GET request. For example, this is the example here we mentioned. GET is added for CS information people.http http/1.0. Here, what you are understanding in this slide is web browsers and web crawlers are two different kinds of the web clients. So both are going to fetch the web pages in the same way. The first the client program is connects to the domain name server, and the domain name server translates the host name into the IP address. This IP address is the number that is typically 32-bit or 128-bit length, and the program that attempts to connect the server computer with the IP address. Once the connection is established, the client program sends the HTTP request to the web server to request a page. The most common HTTP request type is GET request. The example is as follows: GET and the resource name you are mentioning. Whenever it requests, it obviously responds with the HTTP with the 1.0 version. And there is another way that a client can also fetch web pages using the post request also. And here what you are trying to understand, the web client, that may be the web browser or the web crawler, may request the server with the get request or the post request. How it differs? The post request is like the get request, except that it can send additional request information to the server. So the post will send the additional request information. So this is about the post request. Now we try to understand crawling the web as in a diagrammatic manner. As up to now I told you that the crawling, so while the crawling is going on, it will be going to crawl throughout the worldwide. So whenever you go with the worldwide, you will be finding so many web servers. Within the web server, so many links are available, and within the web server and one web server to another web server, that may be navigated and trying to find the relevant information. As part of the crawling the web, so the web crawler connects to the web servers to find pages. Pages may link to other pages on the same server or on the different servers. So here you see here the crawler search engine.com. Then it is going to communicate with www.bcc.co.uk, and again here within that they will be having links within them, and they are having the interaction with the www.whitehouse.gov, and there is another connection, that www.cnn.com. Within that there is a news to this one. So within the web server and one web server to the another web server, the crawler will crawl. So this is about the crawling the web. As part of the crawling the web, we understand that what is meant by a crawling and what is the responsibility of the crawler. Finding and downloading the web pages. We are simply calling them as the crawler. So what it is? Finding and downloading web pages. Finding and downloading web pages. And the program which downloads the web pages, we are calling them as the web crawler. And we are trying to understand web server, and there are two clients, web browser and web crawler. And we come to know how the web client is going to communicate with the web server and how it is going to get the information. So when the web client has sent the request, obviously that is connects with the domain name system. What it can do, the domain name system is going to convert the host name into the IP address. So that may be the 32-bit length, or different networks on it is a 128-bit length. And accordingly, once the connection is established, so the server is going to respond accordingly. So here the web client and web server is going to interact and share the information. Next, we are going to understand the web crawler in detail. So the web crawler, what is web crawler? Just now we discussed that the web crawler has two jobs. What are the two jobs? Downloading pages and finding URLs. Downloading the pages and finding the URLs. So the crawler starts with set of seeds. The crawler starts with what? Set of seeds, which are set of URLs. We can simply call them as which are set of URLs given it as parameters. URLs given it as the parameters. These seeds are added for what? Request queue. These are all the seeds are added for the URL request queue. The crawler starts fetching the pages from the request queue. from where the crawler will get the information or the pages from the request queue. You try to understand here the crawler or the web crawler, we are simply it is having two responsibilities. One is downloading the pages and finding the URLs. The crawler starts with the set of seeds. The crawler starts with the set of seeds. What are the seeds here? Which are set of URLs given to it as set of parameters. URLs or the set of seeds. These seeds are added where? In the URL request queue. These are added to the URL request queue. The crawler starts fetching the pages from the request queue. The crawler will fetch the pages from the request queue. Once a page is downloaded, it is parsed to find link tags that might contain other useful URLs to fetch. So once it downloaded the pages, and it is going to find the new links and new tags associated with them, and that may be passed to find link tags that might contain other useful URLs to fetch. As part of this process, if the crawler finds a new URL, if it finds the new URL, what it will do, that it has not seen before. It didn't see even before at any time. At the time, what it will do, it added to the crawler's request queue. That's what we are simply calling it as frontier. We are also calling it as the frontier. Try to understand. So here, downloading the pages and finding the URLs is the responsibility of the web crawler. These are all as the set of seeds. What are the set of seeds here? URL request queue is maintaining all the requests. And whenever the crawler starts fetching the pages from the request queue, once a page is downloaded, it is parsed to find link tags that might contain other useful URLs to fetch. The crawler finds the new URL. Whenever the crawler finds the new URL that it has not seen before, it is added to the crawler's request queue, or simply it is called as the frontier. Up to now, we understand that what is crawling the web. As part of the crawling the web, how we are going to crawl the web and how we are going to identify the documents. And the next concept is the web crawler. They are the two concepts up to now we covered. And the third one is freshness. And the third concept is the freshness. When you heard the word, you try to understand what is meant by freshness, what it is indicating. In simple terms, I will tell that fresh, it is always indicating it is very new. It is very new. Here, I will try to explain with an example. For example, I am maintaining my website. In my website, I am able to maintain the search engine subject in a more detailed manner. So whenever I am trying to update, or whenever I am able to enhance my website in a more detailed manner, I am trying to add so many documents in day-to-day life. So previously I have added a few of the documents for my search engine subject. Today I have added some more pages to my subject. So whenever I find any new information, I replace the old information with new information. Then obviously the page associated with any link, that becomes stale copy. But whenever you click on that link, you always try to get the old information. That's what we are simply calling it as a stale. That is not the fresh. It is the opposite to the fresh. Whenever you are adding documents to your website, those documents need to be updated immediately, and whenever the crawler is going to find the documents, those documents need to be identified which are updated very recently, though they will be called as fresh documents. Now we will go points in detail. Web pages are constantly being added, deleted and modified. This is a familiar thing, we know that. So web pages are added, deleted and modified regularly. And to keep an accurate view of the web, To keep an accurate view of the web, a web crawler must continuously revisit the pages it has already crawled to see if they have changed in order to maintain freshness of the documents collection. Freshness of the documents. All the time it needs to keep up revisiting to keep up the new pages. The opposite of the fresh copy is what I told you, that stale copy. So which means the copy that no longer reflects the real content of the web page. It is no longer reflects the real content of the web page. And one more point you try to observe here. HTTP protocol has a specified request type. We are having a head that makes it easy to check for page changes. The head request returns only the header information about the page. Only the header information about the page, but not the page itself. Only the header information. When you go with in a more detailed manner, the web crawler can't update every page immediately as it changes. It's a very difficult task for the web crawler every day to maintain updates. When you go in more detail about freshness, web crawler can't update every page immediately as it changes. The crawler needs to have some metric for measuring the crawl freshness. Obviously, it requires some metric to measure the crawl freshness. Under the freshness metric, a page is fresh if the crawl has most recent copy of the web page. This is what I explained as an example. So, what is freshness? A page is fresh if the crawl has the most recent copy of the web page. For example, I updated about one particular topic, search engines, about the freshness in today's class, whatever I told you, I immediately updated in the website. Previously, I maintained the another information. Whenever you try to get the information, so whenever you click on the particular link, it is going to get the link or the information whatever I updated today only. So that's what the freshness it is indicating. But the stale otherwise. Freshness is then the fraction of the crawled pages that are currently fresh. This is the simple definition for the freshness. We can, in general words, freshness is then the fraction of the crawled pages that are currently fresh. So this is about the freshness. Under the age metric, so there is a one metric, age is the one of the metric. The page has age 0. The page has initially age 0 until it is changed. Until it is changed. And then its age grows until the page is crawled again. So here you try to understand the page has age 0 until it is changed. And then its age grows until the page is crawled again. So this is about the freshness, and the freshness is indicating that a page fresh if the crawl has the most recent copy of the web page. The opposite word for the freshness is the stale copy. The next concept is about the focused crawling. So as we already studied about this focusing, so what is meant by focus or topical search, you try to understand, or the vertical search. A search engine that focuses on the specific topic. If the search engine is focusing on the specific topic of the information, that's what we are calling it as a focused crawling. For example, if you want to find out any particular movie, instead of searching for in a scattered manner, you particularly go for any particular website. In that website, you are going to get the particular information about the particular movie. So here the information is related to only particular specific topic. So for instance, a website about the movies users might want to access to search engine that leads to more information about the movies. So that's about the example here. And we are also calling the focused crawling is also with another name. That's what we are calling it as vertical search, can provide higher accuracy than the general search, because this is only particular about the focusing on the particular topic. So it will be able to provide more accurate information or the accuracy than the general search. And here the computational cost of running a vertical search is also will be much less than the full web search. So according to the accuracy and according to the cost, it is better than the general web search. And a less expensive approach, it is also the less expensive approach. So this is about the details regarding to the focused crawling. In this slide we are going to know about the deep web. So what is meant by deep web? Try to understand. Not all the parts of the web pages are easy for a crawler to navigate. There are huge collection of the documents are available. Whenever a person is trying to search any information, the crawler is not able to crawl all the documents available on the web. It is only restricted to few pages only. There are remaining pages that are not possible for the crawler to crawl. So we are going to know about it one as part of the deep web. Sites that are difficult for the crawler to find are collectively referred to as deep web. We can also call it as the hidden web also. We are also calling it as the hidden web. Deep web is over 100 times larger than the traditionally indexed web. It is generally bigger than the traditionally indexing web, although it is very difficult to measure this accurately, because as we understand it, as part of the size, it is more in the size. And when you see most sites that are parts of the deep web falls into the three broad categories. What are comes under the deep web? There are the three parts. So one is private sites that are intentionally private. So these people are not giving the chances to the crawler to get the full information about their sites. So they have no incoming links or may require you to log into the valid account. Then only they will give the chance to get the information about those documents. And form results or sites. So if you can fill the form only, then only they will be able to provide the information about those documents. And scripted pages or the pages that are use JavaScript or different languages for the that's what client languages in the web page. So they are the three broad categories. So private sites are intentionally private, form results are sites, scripted pages or the pages. And the next concept is about the sitemap. The biggest problem in crawling the web arises when the problem will arise if the site owners cannot adequately tell crawlers about their sites. So some of the owners do not reveal the information about their sites. At the time it is a difficult task for the crawler to maintain the information. So at the time the site owners sometimes have the data that they would like to expose to the search engine, but they can't. Because there is no reasonable place to store the links. So here the problem is solved by the sitemaps. Sitemaps solve both the problems of these problems. Here, what is a sitemap? A sitemap contains list of URLs. It contains a list of URLs and the data about those URLs, such as modification time and modification frequency. So here, some of the owners are not able to provide the information about their websites. So, and some of the people are not able to expose their document for the people. Those problems will be solved by the sitemaps. As how it is going to solve, this maintains the list of URLs and data about those URLs, such as modification time and modification frequency. This is about the sitemap.
Next topic is distributed crawling. Try to understand whenever the crawling is going on, there is the difference between crawling the website and crawling the entire web. For the purpose of crawling the entire web, this distributed crawling will play an important role. If you see here, for crawling individual websites, a single computer is sufficient. However, crawling the entire web requires many computers. So if you want to crawl the entire web, we require many computers. There are mainly three reasons why we are going for the distributed crawling. If you see here, one of the first reason is use multiple computers to put the crawler closer to the sites it crawls. So we are going to place the computers near to the sites. So that is the point. If you see here, to put the crawler closer to the site it crawls. Whenever the computer is very near to the near to the computer, then it is very purposeful. Then it is very useful here. And if you observe the 2 points are discussed here, long distance network connections tend to have lower throughput. So long distance network connections tend to have the lower throughput. So that means fewer bytes copied per second. Only the fewer bytes will be copied, and higher latency. If you see higher latency, obviously that's about which takes longer time to cross the network. It takes the longer time to cross the network. That's why this is the one of the reason for putting the crawler closer to the sites it crawls. And another reason is reduce the number of sites the crawler has to remember. Reduce the number of sites the crawler has to remember. If you see here, if there are more number of URLs, all the URLs need to be remembered by the one crawler. It's a very difficult task. If you maintain more number of crawlers, then all the URLs need to be remembered will be reduced. So reduce the number of sites the crawler has to remember. A crawler has to remember all the URLs it's already crawled. If it's already crawled, so all the URLs it has to be remembered. So, and all of the URLs it has to be queued to crawl. This is the another reason. Second reason is reduce the number of sites the crawler has to remember. And the next another reason is computing resources including. So what are the computer resources including? So the reason is that crawling can cost a lot of computing resources, including CPU resources for parsing and network bandwidth for crawling pages. So it is going to take and utilize the CPU resources in a more efficient way. So here the CPU resources for the parsing and the network bandwidth for the crawling pages. Crawling a large portion of the web is too much work for a single computer to handle. So here if you understand, crawling a large portion of the web, is too much work for a single computer to handle. That's why we are most probably preferring for the distributed crawling. There are the three reasons. So this is the last reason. And here if you understand more clear about distributed crawler, a distributed crawler is much like the crawler on a single computer. So it is like the crawler on the single computer, it seems to be, except instead of single queue of URLs, there are many queues. So it consisting of more number of queues, obviously that will be stored more number of URLs. So here what you are trying to understand from this point is a distributed crawler is much like a crawler on the single computer, except what? So instead of a single queue of URLs, there are many queues. The distributed crawler uses a hash function to assign URLs to the crawling computers. So here one of the hash function is here we are using, obviously that is used to assign the URLs to the crawling for the computers. So this is about distributed crawling. And the next concept is about crawling documents and email. Here what about crawling documents and email? Here when you try to understand, obviously web is a tremendous information of resources. So web is tremendous information resource. So because a huge collection of the documents and the millions of the documents are available on the web. A huge amount of the digital information is not stored on the websites. So we know that the huge amount of the digital information is not stored on the websites. It is not stored on the websites because there is a lot of digital information is available. All the time it is not possible to store the huge amount of the data. Now if you see, we will consider the information that you might find on a normal desktop computer. We will consider information that you might find on a normal desktop computer such as email, word processing documents, presentations or spreadsheets. So if you see here, generally a desktop computer consisting of these documents like emails, word processing documents, presentations or spreadsheets. This information can be shared, can be searched using the desktop search tool. Generally, this is the information which you can store in the desktop. This entire information will be searched by the desktop search tool. And in general, in companies and in organizations, enterprise search will make use of documents on the file servers. Will make use of documents on the file servers or even on employee desktop computers in addition to local web pages. So if you see here, as part of the crawling documents and the email, we come to know that web is a tremendous information resource. Huge amount of the digital information is not stored on the websites. When you try to understand in a more detailed manner, generally a desktop search tool, why we are using the desktop search tool, the documents available on the desktop computer like email, word processing documents, presentations or spreadsheets. And whenever you will be having a company related information, so the enterprise search will make use of documents on the file servers or even on employee desktop computers. So in addition to the local web pages, when you go for some more details about here, many of the problems of the web crawling change when we look at the desktop data. There are many problems will be changed when we see or when we look at the desktop data. In the web crawling, just finding the data can be a struggle. So we know that in the desktop, finding the data can be a struggle. On a desktop computer, the interesting data is stored in the file system with familiar semantics. So with the familiar semantics, the data is stored in the file system in the desktop computer. And when you go in detail, finding all the files on the hard disk, finding all the files on the hard disk is not particularly difficult. Finding files on the hard disk is not particularly difficult since file systems have directions, file systems have the directories that are easy to discover, They are easy to discover. In some ways, a file system is like the web server. But with an automatically generated sitemap. So this is about finding all the files on the hard disk. And there are unique challenges in crawling the desktop data. However, the first concerns, so they are about update, speed, disk space is another concern. So these are the concerns. There are unique challenges in crawling the desktop data. However, the first concern is about the update and the speed, and disk space is the another concern. So this is about the crawling documents and email. As part of the crawling documents and email, what we are trying to understand is about the web, and web is a huge or a tremendous information resource. As part of the desktop search tool, what we are going to find, and as part of the enterprise search, what we are able to find, and what are the problems you are going to face whenever you are going to work with the desktop data and whenever you are accessing the data with the hard disk. So this is about the crawling documents and the email. The next topic is about document feeds. Try to understand what is a feed and what is the importance of the document feed and where we are going to work with the document feed. Here, if you see some of the points about the feeds, web or desktop crawling. Web or desktop crawling, we assume that any document can be created or modified at any time. So when you observe the web, in the web there may be that having a lot of chances, a number of chances that at any time the documents may be added, and at any time the documents may be modified, and at any time the documents may be deleted. So as part of the web, number of documents are adding in our day-to-day life and updating and deleting. However, many documents are published. So whatever the documents are added, they will be published, meaning that they are created at fixed time and rarely updated again. So here, as part of it, they are created at the fixed time and rarely updated again. So the documents which are added to the web, so they will be created and at fixed time intervals, and they will be rarely updated. For example, news articles, blog posts, press releases and emails are some of the documents that fits this publishing model. They are the examples for and they will be fit for the publishing model. What are they? News articles, blog posts, press releases and emails are some of the documents that fit this publishing model. Most information that is time sensitive is published. So if you see here, there is a sensitivity for the time. The most information that is time sensitive is published. Each published document has an associated time. Each published document has an associated. What are the documents are published that is associated with the particular time? Published documents from a single source can be ordered in a sequence called document feed. Here you will be having one particular word, document feed. What is the document feed? Try to understand. So we are trying to understand in the web, number of documents are adding in our regular days. Whatever the documents are adding, so they will be published and they will be having a particular time, and they are updated very rarely. Whenever the published documents, each published document has an associated time. Each published document has the associated time. Published documents from the single source can be ordered. So whatever the published documents from the single source, they will be in a order, in the sequence. They will be ordered in one particular sequence. That sequence we are calling it as a document feed. So what is a document feed? Published document has associated time. Published documents from a single source can be ordered in a sequence called document feed. And when you go in detail about document feed, a document feed is particularly interesting for crawlers. This is particularly interest for the crawlers, as we are already familiar with the crawlers. What the crawler responsibility? Crawler is going to identifying and downloading the pages. From where it is going to identify, so it is going to take the support of this one. So a document feed is particularly interesting for crawlers, since the crawler can easily find all the new documents by examining only at the end of the feed. What it is doing, it is going to find all the new documents by examining only at the end of the feed. So there is a feed and all the documents are added, whatever the documents, and it is going to see at the end of the feed for identifying the new documents. And we can distinguish two kinds of document feeds. We will be having two kinds of the document feeds. One is push and another one is the pull. One is push and another one is the pull. So we try to understand what is a push feed and what is the pull feed. A push feed alerts the subscriber to the new documents. A push feed alerts the subscriber to the new documents. This is like a telephone which alerts you to an incoming phone call. So if you try to understand the push feed, which is going to alert the person, which is going to alert the subscriber to the new documents. So this is like the telephone which alerts you to an incoming phone call. So if you are having a phone mobile or a phone land phone, whenever you will be having a ring to the phone, you are able to be alert immediately. So this is what the push feed. And a pull feed requires the subscriber to check periodically for the new documents. As part of the pull feed, he has to check, and he need to check himself periodically. A pull feed requires the subscriber to check periodically for new documents. This is like checking your mailbox for new mail to arrive. So if you understand these two feeds, push feed and the pull feed. Push is an example, which is the telephone which alerts you to an incoming phone call, and pull feed, which is to checking your mailbox regularly and periodically. So here, as part of the push feed alerts the subscriber to new documents, as a pull feed requires the subscriber to check periodically for new documents. For the push feed, the example is telephone which alerts you to an incoming phone call, and the pull feed checking your mailbox for new mail to arrive. So this is about push and pull feeds. The next concept is about the conversion problem. So what it is? What is a conversion problem here? So as we already know that the web consisting of a huge collection of the documents may be in a variety of the formats like PDF, HTML, XML. There are a number of formats that are available. So they are all in different formats. So whenever trying to convert in one format to the another format, there may be have the chance for getting few of the problems. So if you see here, search engines are built to search through text. So obviously you are able to search the text in the search engines. Unfortunately, text is stored on computers in hundreds of incompatible file formats. So the text is stored in the computers in hundreds of incompatible file formats. So the text is stored in the computers in the different file formats. There may be the incompatible. Standard text file formats include raw text, RTF, HTML, XML, Microsoft Word, ODF like open document format, and PDF. So there are some of the standard text file formats. These are all the different text file formats which are very standard, and the most common way to handle a new file format is, what is the way to handle the new file format? The most common way to handle a new file format is use a conversion tool. Use a conversion tool that converts the document content into a tagged text format such as HTML or XML. So if you see here, web is a huge collection of the documents. The web consisting of different variety of the standard text file formats, which includes RTF, HTML, XML, Microsoft Word, ODF, and PDF. The most common way to handle a new file format is use a conversion tool. We have to use the conversion tool that converts the document content into a tagged text format such as HTML or XML. So this is about the conversion problem. So with this, I would like to conclude all the topics of this session. So as we are already seeing that what is meant by a crawling, and what is meant by crawl and feeds. what is crawl and feeds. As part of the crawling the web, we have seen how to retrieve the pages, what is meant by a web crawler, what is focused crawling, what is freshness, what is deep web. These are all covered as part of the crawling the web. And we already seen that what is a sitemap and distributed crawling. And then after we come to find crawling documents and email, and the next one is document feed, and finally we discussed about the conversion problem. With this, I would like to conclude the session. Thank you one and all.